Hello and welcome back for another math mini lesson. I hope you've had a fantastic week. Today's lesson is going to be based on a 5th or 6th grade math topic. So here's our learning target for today. I can use charts or factor trees to find the greatest common factor. And when we think of greatest common factor, I want you to think of the biggest possible number. And why do we use greatest common factor? Usually it's so that we can evenly share different quantities. So when I think of different quantities, think of, for example, going to a supermarket and finding hot dogs in packs of 12s and hot dog bread in packs of 8. Those are two different quantities. But in this situation, what if I have two different quantities and I want to somehow divide them up but make equal groups? So what if I want equal groups, but I want the same number of items in each group? So I might have different numbers of each one, but I want to make sure everyone has the same. And another thing to know is I want to know how many ways I can create this group. How many groups can I make? What's the most I can get with a limit? So with greatest common factor, I have a limited quantity and I want to make the most possible groups with what I have. So let's think of some success points. And two things to know. One, it is really helpful if you know your division facts. And I'm even going to also say your multiplication facts too. Because we're taking numbers and we're breaking them up into smaller pieces. And sometimes we can think of it as just dividing in equal shares. But some people also think of it in terms of multiplication. They think of two numbers that make something else, factors. So having your math facts is pretty helpful, or even having some type of reference for it. Another thing that's helpful if you're using the factor tree strategy is being able to recognize your prime numbers. And prime numbers are just numbers that only have two factor pairs. There's only one way to multiply and get it. So for example, if I think of the number 5, the only way I can get 5 is 1 times 5. That's one way. So it only has two factors. But if I think of the number 6, I can do 1 times 6 or 2 times 3. So this would be a composite number, meaning I have more than two factors, whereas 5 would be a prime. It's only divisible by 1 in itself. I can only multiply by 1 in itself to get it. So for this strategy, it's pretty helpful to be able to recognize prime numbers. So if you need to, you can just go back to this page. I listed all the prime numbers right over here from 2 up to 30. And that's usually what 5th and 6th graders are going to get. If you have numbers that are more complicated, it's probably for an older grade. So let's get into a situation and think more about factors. And well, one point I really want to make is a lot of people kind of mistake factors and multiples. So just think of the idea there are very few factors, meaning it's very finite. So if I think of the number 6, these are the only numbers that make 6. But I can have many multiples, many of them. They keep on growing. As a matter of fact, it's infinite. So if I think of the number 6 and I'm thinking of multiples, I can keep on just repeatedly adding by 6 forever and ever and ever. It's never going to end. So when we think of these situations, do we want numbers where I have a finite number of quantities? I have one set and I don't have more. I'm just breaking up that one set. Or is the problem asking me to take that number and make repeatedly more, like create a situation where I have more and more of them? So that's just another important point. Do I want to factorize, break it up, or do I want to create more with the same number, repeated addition? Okay, so now we're finally ready to jump into a situation. So let's read this first problem. Zoe is serving vegetables at the soup kitchen. She has 12 carrot sticks and 18 baby potatoes that she wants to evenly divide. That's our big clue, with no food leftovers. What is the greatest number of plates Zoe can prepare? So we want to know the most plates she can prepare. And for this, I'm going to use a strategy of a table, which is great when you're just starting out. And just think for a minute, pretend I had 2 plates and I'm trying to share my 12 carrot sticks. I'm going to put CS for carrot sticks. And I'm just sharing them. And this is something I can see even younger kids doing. So I have 8, 10, 12. They're just sharing and making sure that now they're out of all their sticks. They've given out all 12. And then I'm going to do the same thing with the 18 baby potatoes. They're just going to evenly share them. So far I've given away 8, 10, 12, 14, 16, 18. So in each group, I have 9 baby potatoes and I have 6 carrot sticks. That's something that kids can do. They can take a quantity and they can evenly try and share it out and see how many groups. But I want to make sure I have the greatest number of plates. So this means a kid would have to keep on using plates and keep on sharing numbers to try and find the greatest number. But with a table, we can do it a little bit faster. So I'm going to draw a table. I am loving my Apple Pen. This makes my pencil is so easy to write on my iPad. And I'm going to put number of plates on one side. And then I'm going to put my carrot sticks here. And my baby potatoes here. And listen to how I'm thinking about the numbers and how I'm multiplying and dividing. I'm using my math facts. So if I had one plate, I can put all 12 carrots and all 18 potatoes. And I've shared them. There's only one plate though, so I didn't have to divide them. I can think for a minute, 12 divided, or over here, 12 divided by 1 gives me 12. I can think 18 divided by 1 gives me 18. So that's my using my math facts. What if I have 2 plates? I'm going to do that same thinking. 12 divided by 2 is going to give me 6. And 18, I'll do it up here, 18 divided by 2 is going to give me 9. And I keep on doing that because I want the greatest number of plates. I want to know how many plates until I can't share. But remember, I want no food left over. So if I have 12 divided by 3, I have 4. If I have 18 divided by 3, I have 6. And if you have trouble, just use your table to help you out. Let's say I have 4 plates though. 12 divided by 4 is 3. 18 divided by 4. Now I have a problem because 18 can't be divided by 4 without an even number. So if I were to do 18 divided by 4, I get 4 and a remainder 2. That does not work in this situation because I wanted no food left over. So I'm just I'll leave this so you can just see it. And I want to just think of the next number, 5. Same thing. 12 cannot be divided by 5, so I already know that's not an option. Let's try the next number, 6. 12 divided by 6, that's 2. And 18 divided by 6 is going to give me 3, so that works. And I'm also realizing that I'm getting less and less, so I'm just thinking in my head, can I get even smaller than 2? And I can keep trying thinking like 7, well, that's not divided. 12, I can't be divided by 7, so I'm going to erase that. I can try 8. 12 can't be divided by 8. So I'm going to erase that. And I'm counting in my head 9. 12 can't be divided by 9. 12 can't be divided by 10. 12 can't be divided by 11. 12 can be divided by 12 to get 1 carrot stick. But then I'm stuck here. 18 cannot be divided by 12 because I'm going to have a remainder again of 6. So I can make a decision here. I can't get any smaller with the carrots, so I can't have more plates. And so I know there's nothing else that can work here, which tells me that my greatest number of plates has to be 6. There's no way I can have more than 6 plates and still have no food left over. So this over here, this 6, the number of plates, is my greatest common factor. And when I have 6 plates, I can have 2 carrot sticks in every plate, and I can have 3 baby potatoes. And this is how the table works. And like I said, it's very helpful if you're just starting out and you're just thinking number by number. How can I break this up? This is great for 4th and 5th graders. But I'm going to show you a different strategy with the next problem. For this one, I'm going to use a factor tree. And for factor trees, again, remember, I need to know those primes. So I'm going to put them here on the bottom just to help us out. And if you need to look at them, you can go back to the other list. 23, 25 is in prime, 27 is in prime, 29, and 31. So that's going to help me out. A lot of primes are odd, except for number 2, but not every odd number is prime, and I'll talk about that in another video. Okay, so for a factor tree, let's read this problem out together. A family is preparing backpacks with school supplies to donate to children in need. They have 16 pencils and 20 notebooks. That's all they have. That is definitely finite, which is going to give me a hint that this is the greatest common factor problem. If they want to make all the backpacks the same with no supplies left over, what is the greatest number of backpacks? So this is absolutely the greatest common factor problem. So I'm going to use the number 16 and 20, and I'm going to use my math facts to help break down a number. And to be fair, it doesn't matter how you break down a number because we're going to go to its tiniest parts. They're prime factors. So all you have to do here is just think, what two numbers can I multiply to make that number up there? I need a factor pair. So for example, with 16, I know that 8 times 2 makes 16. And I'm going to look at my list and I see that 2 is prime. So I'm going to circle it. I'm going to put that as a criteria for success, to circle the primes. That's going to be a big key. And I'm going to keep going down. I'm going to break 8 down even more. I know 4 times 2 makes 8. And again, 2 is prime. And I know 2 times 2 makes 8. And I know I'm done because every single number here, they're all circled. They're all primes. I can't break them up anymore. So I'm going to do the same thing now with 20. I can do 5 times 4 makes 20. And looking at my list, I see 5 is prime, so I'm going to circle it. And we've done 4 before, so I'm going to do 2 times 2. And I know 2 is prime. So I can't break it down anymore. What's confusing sometimes is sometimes people look at this number, but I've broken it down, so don't worry about it. It's been broken down to prime factors. And now what I'm going to do is I'm going to take 16 and 20, and I'm going to make a list. I'm going to list the prime factors. So for 16, I have 2 times 2 times 2 times 2. And for 20, I have 2 times 2 times 5. And now I'm going to kind of play a game. It's almost like Go Fish. I'm going to look for what do they have in common. And I see on both lists, they both have a 2. So I'm going to circle these so I don't use them again. 2. And I'm keep looking. It's kind of like playing Go Fish. Are there any matching partners? And I see another 2 and 2. So I'm going to write 2 again. And now I'm going to look again. And I have a 2 here and I have a 5 here. So they can't match each other. So there's nothing else I can do. So what I can do to find the greatest common factors is find the product of these two numbers, which is 4. And that would make it the greatest common factor. So I can have 4 backpacks. And that makes sense because if I have 4 backpacks in my head, that means I'm going to have 4 of these pencils and I'm going to have 5 of the notebooks. But the question didn't really ask that. They just want to know how many backpacks can they fill up. So looking at these strategies, try and think which one makes the most sense. Now, the next problem, I'm going to use both. And again, you can decide which one makes the most sense for you. So let's take a look. Lila is making stationery sets from 8 sheets of paper and 12 envelopes. So again, these are finite. That's all she has. She doesn't have more sets. She wants the sets to be identical with no envelope left over. So in your mind, you're already thinking you're going to do an even share, and there are 2 quantities. So this is already telling me it's going to be the greatest common factor. What is the greatest number Lila can make? And I'm going to try this using both, just so you can see both. So we'll start with a table over here, just so you can review it. And I want to know how many sets she can make. What's the number of sets? And we have paper with 8. And we have envelopes with 12. So if I start with 1, which is the easiest, I can put all 8 pieces of paper and I can put all 12 envelopes, nice and easy. Now I start thinking again, what if I have 2? Can I divide with 2? Absolutely. 8 divided by 2 gives me 4. 12 divided by 2 gives me 6. So that works too so far. That's my greatest common so far. It's my little doggy just jumping around. What if I have 3? Can I divide? 8 cannot be divided by 3. So I'm going to just get rid of this because there's not an even share. We'll try 4. Can 8 be divided by 4? Yep, 8 divided by 4 is 2. Can 12 be divided by 4? Yep, 12 divided by 4 is 3. I'm just doing that in my head. And I'll try the next number, 5. 8 can't be divided by 5, so we're going to delete that. And I'm going to think in my head, can 6 work? No, 8 can't be divided by 6. So now I'm kind of getting somewhere. I'm noticing something. And I'm also noticing that we're already getting very low on these numbers. So 6 doesn't work, 7 doesn't work. I can try 8. Well, 8 divided by 8 gives me 1. But 12 divided by 8, nope, that gives me a remainder. So this does not work, which tells me that this is my greatest number. So here is my greatest common factor. I can have 4 sets with 2 pieces of paper and 3 in each one. And we'll try it also with our numbers here in our factor trees. Here's 8, here's 12. And again, it doesn't matter what pairs you're using, because we're going to go to our base numbers, our factor pairs that have to be prime. We want to get to primes. But I'm going to list them on the bottom just for you again. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, just to keep helping you. So I'm going to start with 8 first. And I know 4 times 2 makes 8. 2 is prime. And I know that 2 times 2 makes 4. So those are my primes. And with 12, I'll do 4 times 3. And I do see that 3 is a prime number on my list. So I'm going to circle that one. And 2 times 2 makes 4. And those are prime. Okay, so let's list those numbers again. For 8, I have 2 times 2 times 2. And for 12, I have 2 times 2 times 3. So again, we're kind of playing Go Fish and see what matches. And I see that 2's match here. So I'm going to write that as a common factor. I see that 2's match here. So that's another common factor. And then I also see that 2 and 3 do not match. So I have no more common factors. So my greatest common factor is going to be 2 times 2, which gives me 4. So again, I get 4 when I use a factor tree. I get 4 when I use a table. Either one makes sense for where you are. You want to make sure that sometimes the strategy you start with, once you get really good at it, you can actually use other ones. So I would love to see 4th and 5th graders using a table first. And then by the time they get to 6th grade, they're using a factor tree to get to those numbers. So I hope this makes a lot of sense to you and you found it really helpful. If you like this video, please share it with your friends. I would love to hear your comments. Give me some feedback. If there are topics you want to know, by all means, please just respond in the comments, or you can send an email to me at sarah@mathminilessons.com. I hope you guys enjoy, and I will see you later this week. Take care.